We can factor by removing a common factor. So if ax plus bx plus cx all the way up to zx, there's a common factor of x. Out it comes, x times everything else, a plus b plus c plus etc. plus d. This is called a complete factorization if x is the greatest common factor of all terms. GCF means greatest common factor. The biggest thing that's a factor of all of them. So 2x plus 16. Well, common factor is 8. The greatest common factor is 8. Removing, you get 8 times 3x plus 2. Here I have a 45a squared minus 9a. Well, a is a common factor, and so is 9. So you pull out 9a, and we're left with 4a squared over 9a is 5a. 9a over 9a is minus 1. 9a times 5a minus 1. 15x squared y minus 10x squared y squared. Okay, there's a common factor of x squared, out it comes. There's a common factor of y, out that comes. 15 and 10 have a greatest common factor of 5, out that comes. And so dividing each of these terms by 5x squared y, well, this over that is a 3. This over that is a 2y. So 5x squared y times 3 minus 2y. Now here we have trinomials, 3 terms. This is the simplest case of what's called completing the square. X squared plus 2bx plus b squared is the square of x plus b. In fact, that's in the previous section, I went through that. A sum squared is square plus twice product plus square. And a difference squared is squared minus twice product plus square. That was going from right to left. Go from left to right, you have to be able to recognize that it is a completed square. We'll do that. Okay, here what we do, 2bx, we take half the coefficient, make it a b, and square that, and it matches to this, and it'll be x plus this b all squared. Similarly, x squared minus 2bx plus b squared. Take half this coefficient, be negative b, square that, you get b squared. It matches this, so this is equal to x minus b all squared. So for example, x squared plus 6x plus 9. Take half of 6 is a 3. That squares to 9, which matches that. So this whole thing is x plus 3 all squared. X squared minus 10x plus 25. Take half of negative 10 is a negative 5. Squares that, it's 25. And since it matches this 25, the whole thing is x minus 5 all squared. So for example, a squared plus 18a plus 21. Well, half of 18 is 9, squared is 81, so it's a plus 9 squared. Here, this method of completing the square works best if the coefficient of x squared is 1. Here it isn't, so I have to go sort of a long way around. 4x squared plus 28y plus 49. 4x squared is the square of 2y. 49 is the square of 7, so far so good. Now this, is it twice 29 times 7? Well, yes, it is. Twice 29y times 7 is 28y. So therefore, this square plus twice product plus square makes the square of 2y plus 7. Now, this is a more general thing. Here's something called, well, I call it the PQ method. X squared plus bx plus c. That factors into x plus p times x plus q if p plus q is b, the middle coefficient, and p times q is c, the last term. And to find p and q, well, I know a number of people, they draw a cross and put, let's see, the product here in the sum, and you put two numbers in the side things which have the right product and have the right sum, and that's fine if you have incredibly fast intuition, which sort of works in small number cases, but really the best way to do it is be systematic. You look among you find all of C's factors and search all those pairs of factors for the one that sums to B. So for example, x squared plus 5x plus 6. Whatever P is, Q has to be 6 divided by P. And then we want to see if P plus Q fits. If P is 1, 6 over P is 6, their sum is 7, doesn't fit. If P is Q, 6 over P is 3, their sum is 5, which fits. So this equals x plus 2 times x plus 3. Here's t squared plus 14t plus 48. Their product has to be 48. Their sum has to be 14. Okay, so if whatever P is, Q should be 48 over P. And we check their sum. And there are various factors of 48. 1, 2, 3, 4, 6. Okay, 1 over 48 over 1 is 48. Their sum is 49. Too big. If P is Q is 2. Q is 48 over 2, which is 24. 2 plus 24 is 26. Still too big. If P is 3, Q is 48 over 3, which is 16. Their sum is 19. Still too big, but it's getting close. If P is 4, 48 over P is 12. Their sum is 16. Not there yet. 5 doesn't work, so we don't check that. If P is 6, 48 over 6 is 8. Their sum is 14. It fits. So this equals T plus 6 times T plus 8. Now we have to watch this one. We got to watch out for. Y squared minus 17y plus 72 is what? Their sum is a negative 17 and their product is 72. Okay, so we have P, Q is 72 over P, and we check the sum. P is 1, Q is 72, their sum is 73. That's the wrong size and the wrong sign. However, we can fix that by flipping P to negative 1, then Q flips to negative 4 to 72. The sum is negative 73, which still is wrong, but at least it's the right sign. Let's try negative 2. 72 over negative 2 is negative 36. Their sum is negative 38. Still no good. 3 doesn't work. It doesn't go, or does it? Oh dear. Maybe I should have checked 3. Well, whatever, it didn't work. If P is negative 4, then Q is negative 18. Their sum is negative 22. It's getting closer. If P is negative 6, then 72 over P is negative 12. The sum is negative 18, almost there. If P is negative 8, Q is negative 9. The sum is negative 17, which fits. So this thing equals x minus 8, y minus 8 times y minus 9. Now here a more general method to factor ax squared plus bx plus c. So now we have a non-1 factor of x squared. Now here we have to find P and Q, whose sum is still B, the negative coefficient, and whose product is A times C. So this is why this is called the AC method. And once you've found such a P and Q, then you write Bx as Px plus Qx. So you write ax squared plus bx plus c is ax squared plus px plus qx plus c. And this will factor by grouping. So for example, 2x squared plus 5x plus 3. We need two numbers whose sum is 5 and whose product is 2 times 3. And 2 and 3 work fine. 2 plus 3 is 5, works. 2 times 3 is 2 times 3, that certainly works. So we write 2x squared plus 5x plus 3. Right, this 5x is 2x plus 3x. So 2x squared plus 2x plus 3x plus 3. You factor this pairs of terms at a time. 2x squared plus 2x has a common factor of 2x times an x plus 1. 3x plus 3 has a common factor of 3, also times x plus 1. Now these two terms have a common factor of x plus 1, which we pull out. And we're left with 2x plus 3 times x plus 1. Now here I'm going to go briefly over why this method works. If P and Q add to B and multiply to AC, then Q is AC over P. So we can rewrite this, ax squared plus bx plus c, as ax squared plus px plus qx plus c. That's from here. And this from here is ac over px. So ax squared plus px plus ac over px plus c. Now I can rewrite c as cp over p. And we can see there's a common factor of c over p for these two terms. Pull it out, you get c over p times ax plus p. This also has a common factor of x, pull it out, times ax plus p. Now we have a common factor of ax plus p between these two terms. So we have ax plus p times x plus c over p. There's also factoring difference of squares, difference of cubes, sum of cubes. This follows from the previous section. X squared minus y squared is x minus y times x plus y. previous section, I wrote it in reverse fashion, multiplying the here, and the other way is factoring. I call this the 99 rule because you have x is 10 and y is 1, then 10 squared minus 1 squared is 99, and 10 minus 1 times 10 plus 1 is also 99. Difference of cubes is difference times square plus product plus square. Again, I mentioned this previous section in the reverse order. I call it the 999 rule because if you set x equal to 10 and y equal to 1, this side on the left, 10 cubed minus 1 cubed is 999. And this on the right is 10 minus 1 times 10 squared plus 10 plus 1 is 9 times 1, 111 is also 999. And sum of cubes, well, it's like this rule, only we swap the sign of the y and the xy. So it's x plus y times x squared minus xy plus y squared. I'm sorry about this. Maybe I should rewrite this later. This is here I summarize all the rules. Removing common factor, here's an example, if you can read it. Factoring by grouping, which I call unfoil. You have two terms plus two terms, factor the first two terms for factor the second two terms. This is so arranged that these are common factor, x plus 2, and that times x plus 3. There's the PQ method, there's AC method, there's difference of squares, and there's difference in sum of cubes. So, some examples. Factor 2x squared y minus 6xy squared plus 3xy. All right, there's a common factor of xy. And what you do is you'll look for the lowest power of x in each term and the lowest power of y in each term. Here, the lowest power is x to the first, lowest power of y is y to the first. So you can pull both x and y out. And when you do that, these terms become 2x minus 6y plus 3. So there we're done. Here's factoring x squared plus 2x minus 15. We need two numbers whose sum is 2 and whose product is negative 15. After a fairly brief search, 5 and negative 3 work. Their sum is 2, their product is negative 15. So this equals x plus 5 times x minus 3. All right, here we are to factor 3x squared minus 16x plus 5. So we now find P and Q whose product is 3 times 5, which is 15. And whose sum is the middle coefficient, negative 16. It's not a very short search finds that negative 1 and negative 15 work. Their sum is negative 15. Their product is positive 15. So you write this minus 16x is a minus 1x minus 15x. So this is 3x squared minus 1x minus 15x plus 5. These first two terms have a common factor of x times 3x minus 1. These next two terms have a common factor of 5 times minus 3x plus 1. But whoops, slightly wrong turn. This is 3x minus 1. This is minus 3x plus 1. They're not the same. In fact, they're opposite. So what we do is we pull out a negative 1 from this, the minus 3x plus 1. And we know what negative 5 times 3x minus 1. Remove a common factor of 3x minus 1. And we're left with x minus 5. So x minus 5 times 3x minus 1. Okay, to factor 49 minus 4z squared. Well, 49 is the square of 7. 4z squared is the square of 2z. It's a difference of squares, so it's a difference times a sum. 7 minus 2z times 7 plus 2z. To factor 8a cubed minus 1. Well, 8a cubed is the cube of 2a minus 1, and 1 is the cube of 1. So this is a difference of cubes. Difference of cubes is a difference times square plus product plus square. So 2a minus 1 times square of 2a is 4a squared. 2a times 1 is 2a. 1 squared is 1. So 2a minus 1 times 4a squared plus 2a plus 1. And here we have factor 27x cubed plus y cubed. 27x cubed is the cube of 3x. Y cubed is the cube of y. This is the sum of cubes. And so the rule is that will be a sum times square minus product plus square. 3x plus y times, and this is the square of 3x minus 3x times y plus square of y. And this expands up. And this is a next step of the cleanup step. You get 3x minus y times 9x squared minus 3xy plus y squared. Here we have factor x squared minus 2x minus 8. Now define P and Q, whose sum is a -2 and whose product is -8. -4 and 2 work. And again, really define these, you want to go through a brief search through all the factors of -8. So you get x minus 4 times x plus 2. Here we have asked to factor 2x squared plus 5x plus 3. So we need P and Q, whose product is 2 times 3, that's 6. And whose sum is 5. Product is 6, sum is 5. 2 and 3 work. 2 times 3 is 6, 2 plus 3 is 5. So write this 5x as 2x plus 3x. 2x squared plus 2x as a common factor of 2x times an x plus 1. 3x plus 3 as a common factor of 3 times an x plus 1. Pull out the common factor of x plus 1, leaving 2x plus 3, and we get 2x plus 3 times x plus 1. All right, and that concludes that part.